Hi, this is Karthikeyan. He's not a great programmer, but a decent one. Unfortunately for now, his brain is not braining. So, in order to bring his brain back online, he needs fuel. He opens Blinkit. He searches Canva. And no, not sponsored. We're too small for that. He clicks order, estimate delivery time, 10 minutes. That's how long it takes for this Canva to reach Karthikeyan. It also means we have exactly 10 minutes to explain how Blinkit works.
First, you have to understand the physics. Traditional e-commerce like Flipkart and Amazon operate on hub and spoke model, which involves giant 200,000 square feet warehouse sit 50 kilometers away the city. That is why you need to wait for 1 day or 2 days. Blinkit destroys this model. They don't see city as a map, they see it as a mesh of polygons. They divide the entire city into small geometric zones. Each polygons follow one strict rule. Delivery time from the center to the farthest edge cannot exceed 10 minutes. Here is a growth hack. If a demand in a polygon rises and delivery times slips to 12 minutes, they don't just hire more riders. They physically split a polygons in half and open a new dark store in a new zone. Cellular metastasis, but for the logistics.
Now let's talk about the node, the dark store. Blinkit has 60 of these in Bangalore alone. These aren't warehouses. They are 2000 square feet of micro fulfillment centers, about the size of large 2-bedroom apartment. Inside, they stock around 6000 SKUs. Unlike Amazon, which uses robots, Blinkit uses muscle memory. Because of the space is tiny and clock is ticking, the robots are usually too slow. A human picker knows exactly where everything is. They use FIFO, first in, first out. The app directs the picker to grab the item that expires soonest, ensuring freshness and reducing waste. The picker packs the order in just under 60 seconds.
But how do they manage inventory across hundreds of stores? This is where the mother house comes in. For every 40 to 50 dark stores, there's one massive mother house, which is about 150,000 square feet. The mother feeds the kids. They use predictive AI to restock dark stores every night based on what you are likely to order on the next day.
Okay, that's the physical layer. Now let's talk about the software layer. How do you handle 50,000 requests per second without the system catching fire? Blinkit isn't a monolith. It's a distributed system running on microservices, built on Java, Go and Python, ostraced by Kubernetes. But here's the hardest problem in the quick commerce. It's not the delivery, it's concurrency. Imagine there's exactly one packet of blue lace left in the dark store. My friend Jackson and I hit the pay at the exact same millisecond. Who gets it? If you rely on only one standard SQL database, both payments might go through. But there's only one bag. One of us is going to be very angry and very hungry. To solve this, they use Redis. Redis is an in-memory data store. It lives in RAM and operates in milliseconds. It implements distributed locking. The moment I hit checkout, the system pings Redis and places a mutex, locks on the specific item for 3 minutes, even if the main database isn't updated yet. Redis knows the item is locked. Optimistic locking at scale.
Next, the data pipeline. You can't run a 10-minute business if your data arrives 2 hours late. That's like driving a Ferrari using a map from 1995. Blinkit uses Apache Kafka as its central nervous system. Rider location, Kafka stream. Inventory update, Kafka stream. Rain in Coimbatore, of course. Speaking of rain, they don't just rely on Google Maps. They use Zomato weather infrastructure called Weather Union. If it starts raining in just one polygon, the system knows instantly. The algorithm adds a rain buffer to the ETA and may surge prices to balance demand. They also use Google's S2 geometry system, dividing the world into mathematical cells to calculate delivery times, time to park, time to climb the stairs, time to take the elevator. Yes, they even track the elevator time.
And finally, the prediction layer. Blinkit uses gradient boosting machines and neural networks to predict demand. They call this slot intelligence. The model considers unusual signals. If it's raining, demand for tea spikes 300%. India vs Pakistan cricket match, chips and coke surge. Valentine's Day, flowers move to the front.
They all use a clever psychological hack. Notice when the rider is about 100 meters away, the map stops showing time and just says, arriving soon, and that's intentional. GPS becomes jittery in the final stretch. If the dot jumps around, you get anxious. By switching to text, they give the rider 30 seconds buffer to find your door without you panicking. All of this, microservices, Redis locking, S2 geometry, neural nets, must execute in under 200 milliseconds.
If the latency exceeds, the app feels low, and then you might switch to Zepto or Instamart. But Blinkit's algorithm works.
And this is Jackson Henry and Karthikeyan enjoying his camper.
Follow for more such content in open source from JIT Wired. This video is not sponsored by Camper.